So this is the last part of our three-part session on basic electrical, okay? So we'll move on today and we'll go a little bit deeper, okay? It's still a basic course. The real nuts and bolts come after this, which we'll do in Cert 4, but for today, you need to know the basic foundation, and that's what we're doing today.
Oh, what time, mate?
Let's have a look at the electric wiring diagram circuit, okay? Do we find that a little bit messy or daunting or
Very
confusing? Sorry?
Very messy.
Very messy. So wiring diagrams need to be broken down into what we're looking at, don't they? So that circuit's got a number of things that's happening in that circuit, and that's why it looks messy, because there's so many things in there. But, you know, I've got a picture here, which we'll look at later, of the more complicated wiring diagram. But even that's not so complicated as some of the ones we look at. But if we remember, we broke down our circuit recently for a single parallel circuit. We looked at one circuit. We can break that down into those sort of circuits, just the simple circuits, okay, even though they're looking complicated. And that's what I'm trying to, I guess, instill into you guys, is how to look at and read a wiring diagram, okay? That's my object today.
Beautiful.
If we look at this diagram, how many components are in there that run the starter motor? So here we have the starter motor. See the starter motor?
Yes, sir.
Okay. How can we discern what controls that starter motor from that wiring diagram?
Switch.
Well, we know there's going to be a switch, but we look at the diagram and work our way backwards.
Yeah.
So there's our solenoid. There's our main battery power. See the positive battery power?
Yes.
Then we can come back from the solenoid and come backwards.
Back to
Where's
the
it
relay.
going to? What's that?
Relay.
It goes to a relay, okay? What controls that relay? That's what we're going to look at next.
Switch.
And who knows what a relay is? A relay is a solenoid switch, okay? It has to have power to the solenoid to pull the switch closed or open, okay? So, what controls the solenoid is along this circuit. Ah, what's that?
Starter button.
Starter button. Come back. Ah, what's that?
Ignition switch.
A what? Ignition switch. Then
Chabi.
What happens to, what's that? If we come back from the ignition switch.
Fuse.
A fuse. And where's this fuse power from?
Start off.
And where's that power from?
Battery.
Main wire.
Is that complicated? Is that hard? When you look at it like that. And that's how we look at wiring diagrams. We go and look at what's joining the wiring diagram. I would be using, even though it's in colour, most wiring diagrams being in black and white, I would use some, not necessarily these particular colours. I normally use a red for the power. I normally use a green for the grounds. I work it out that way. And when you highlight the wiring diagram, whatever you're looking at stands out and becomes much more clear then. So, you know, it's not that complicated, and that's where we're going with this today. Look at this. I have one circuit I've made. Watch this.
Switch.
Okay? Pretty cool, eh? So, if I come back to the battery, there's my battery. And I follow up to here. Here's my box. Here's where we're joined. Can we see that? Yeah. Follow that up. Here we have what? What's that? That's like a fusible link. That's the main fuse going into what?
Main wire.
The main fuse box.
Main fuse box.
From the fuse box, we've got power. On this side, we've got a ground. And if we follow the ground up, there's a ground block here, and on this side is connected to that ground block. On this side is connected to the power. So how simple is a circuit like that? Okay. This is part of a complete wiring harness in a car, and we've just taken part of that out and put it onto that board now to make it a bit more simpler. We have a switch as well. See the switch? So behind the board, we've got wires coming from this main wiring harness, that goes back to the switch. and it powers the switch and it grounds the switch. And the switch will change polarity to whether the window winder goes up or down. Doesn't get much simpler. It looks complicated, but it's not that complicated. And we have to learn how to dissect a wiring diagram, okay? So I'll just move on. I've just made it a little bit simpler. All these components are still there, but I've taken all the wiring out that we don't need. And I've just left the wiring of what we do need for the starter circuit. It's still a bit messy, but it gives you a better idea, okay? So just to show you. So what parts are making up that starter motor? Who can tell me? What components? We started before. What have we got?
What was that?
What are the components that make the starter motor work?
Relay.
We got a relay, we got a battery, ignition, what else?
Fuse.
Fuse,
Switch.
Data button.
yeah, all those things.
Switch.
Out of the
Okay.
class.
Sit down and we'll sign them
Sit
now.
on the floor.
Sit down.
Light comes in the front.
All right, now, I'm going to, if you can pass these around, I'm going to pass these wiring diagrams around. I don't want you to be too worried about them right this second, okay? What I want you to do, I want you to watch a video, okay? Last time we showed the video of Jeff Smith, everyone thought he spoke too quick. Everyone thought how boring it was. Okay, I'm going to show you someone else today. I'm going to show you a video from a friend of mine in America called Paul Denner. Paul Denner, okay, he has a lot of YouTube training, very good training by the way. He's going to talk about how he dissects wiring diagrams in a certain wiring diagram, okay? I know you guys get a bit bored with videos and you get a bit talkative. Please don't. Please listen, because the information he gives you will help you when I ask you to do something on this wiring diagram, okay? So it's important that you listen. Well, he's going to dissect a airflow sensor. It's on a Toyota. It's an old style vane type that would open a flapper up and down. We don't see those type of airflow sensors anymore. But the idea is how to read the wiring diagram, not so much whether it's relevant for our modern cars or not, okay? So can we please pay attention as we watch this video? I'll just play it.
The purpose here of this vane airflow meter, if you ever run into one, know that this info's here. But I think for us right now, the time would be better served just talking about the extra 2 wires and how it's a fuel pump control, and really more or less just helping us dissect a wiring diagram. So I think that would be the most important part. Then we'll move on to the hot wire stuff. And again, if you ever run into one of these, you have the info here. Let's use the time to review the diagram. So starting at the airflow meter itself, internal, we can see some familiar pieces, right? I see a resistor with a line going through it, which is what on a wiring diagram? What would that be a symbol of? It's a thermistor. It's a thermistor. That's a thermistor symbol. Get used to that. When you see that, actually, I should correct that. Technically speaking, that would be a variable resistor, because you'll see fuel pump sending unit circuits that are drawn like that are not thermistors, but this is a thermistor. Okay, and a thermistor uses a signal and a ground, and we said that signal wires are never shared, right? But what can be shared between other sensors? A ground. So right off the bat, without looking at anything down here, I know that this wire is a ground. That's a thermistor, and it's sharing a wire with a potentiometer. This would be a symbol of a potentiometer when you see a resistor and a needle. Wiring diagram symbol of a pot, and they're sharing a wire. They can't share the reference circuit. It's what we just covered, 5-volt reference yesterday. Why can't they share the reference circuit? Do they share a reference circuit in a sense? That's right. That's what I'm talking about. Let's go to my chapter 9 again real quick. We just covered this yesterday, but what I'm asking you guys right now is a thermistor signal wire is technically tapped into the 5-volt reference circuit. my throttle position sensor uses a 5-volt reference circuit, or a potentiometer uses a 5-volt ref. What I'm describing to you is we can't share the reference of a potentiometer with a thermistor. Can we share it with other pressure sensors and other potentiometers? There's my VAF. This is what we're talking about right now, this vane airflow meter. Can I share the reference of the TPS with the reference of the VAF? And the answer is yes. Externally, we can share it because it stays at 5 all the time. But you cannot take this wire and share it with the ECT. Why? What would it read all the time on the ECT? It would be 5 all the time. We'd be feeding voltage this way. It'd feed voltage this way. This would always be 5. This resistor would be irrelevant. We'd have 5 coming this way, 5 coming this way. The voltage sensing circuit would always read 5. This would still do its job. It would still change resistance with temperature, but we would only have a current flow change, not a voltage change. Because what's the regulator going to do? As the resistance drops of this thermistor, this regulator is just going to pump out more current to keep it at 5 volts. That's what a regulator does. Do you guys understand? We cannot share a reference between a thermistor and a potentiometer externally from the computer. Is it tapped into the same regulated circuit? It is, but that's internal to the computer and it's isolated by a current limiting resistor. Let's go back to 12. So, do you understand with that conversation, all we're looking at, just keep your eyes focused right here. Don't look beyond that red square. Do you understand that this shared wire could potentially be, we have 2 different sensors and we can share a reference, we can share grounds, but certain things we can't share a reference with. So what does that make that shared wire in the conversation we just had? This being a thermistor and this being a potentiometer, we cannot share the reference. This has to be, no question about it, it has to be the ground for these 2 sensors. All we're doing right now, I know this is an older design, you may never see one, but that's not the point. The purpose here is to kind of put this together and recognize signal wires, ground wires, reference wires without having to do a ton of research. Just looking at the diagrams all we need with practice. So that's the ground for this circuit. This is the ground. I have this written down below, but we'll write it here. That makes this my thermistor signal. And what is the thermistor in this vane airflow meter? This happens to be an IAT sensor, an intake air temp sensor. That would be the signal wire, that's the ground. And then another clue for you guys would be the pointer on a potentiometer would be your signal wire. So we have 2 wires left, right, on the pot. We have the ground identified already, so we just have a signal and a reference. The signal would be the pointer. And so what's that make this circuit? This is my 5-volt ref. And you can see down below that I have this all identified for you. I have it written down right there. Just a little sensor review. All right, so that's this is actually a 7-pin design. That's 4 of the wires. We're sharing a ground, and then we have 2 extra wires for this. And on this design, it actually operates the fuel pump. So let's use this for 2 things. One, Toyota still calls their fuel pump relays circuit opening relays. And 2 would be, let's use this again as a diagram review. This will be a nice review of chapter 3, power and ground side switching, and being able to dissect this fuel pump circuit. And maybe someday you'll see one of these, who knows. But let's use this for fuel pump operation. I like to start at a pump, especially when I can see there's a ground wire right here. What does this wire have to be? Has to be a power. Let's follow this, see where it goes. It goes off the page to the fuel pump terminal on the data link connector. That was a under hood data link connector. Then it comes up to here. And so power's not going to come from the data link connector. That means power has to come from this circuit. Does everyone follow that? So that means this has to be a power feed. And then do we draw through that coil or do we stop? So I'm trying to map out this circuit. Where's this power coming from? This is key. This is absolutely key. What does a coil of wire need to work? To make a magnetic field on a coil of wire, what do we need? I need current flow. To have current flow, what do we need? need to have power, need to have a ground. It's not going to come from this. It comes, follow it over this way, it goes off the page. I have a hot and run giving you that information. But even without following it off the page, if I would have just come up over here and stopped here, I can take this further. What does this wire have to be? No question about it. It has to be a ground. You guys following this? It's very simple. Practice will help you with this. This has to be a ground. So follow this one. Where is this going? Over this way to this vane airflow meter. Now we know what this switch is doing in this meter. Is this switch is going to ground this coil. Okay? So it has to go to ground. Where's this switch going to ground? We can stay the same color here. We don't necessarily have to switch, because once this switch closes, then these two wires are going to be the same polarity. Let's follow this guy, see where it goes. It comes to another splice. This can be difficult. Do we draw through this coil? Nope. Do I draw through this resistor? Nope. Don't do it. What's this coil need to work? It needs a power and a ground, right? And what are we saying this green circuit is? It has to be a ground. So even without mapping the rest of this out, which you're going to see goes to a ground, what do I know about this circuit right here? This is a power. Has to be a power. No question about it. This has to be a power. Where's it going? Hot and crank. You guys see how this is working? All right, so let's follow the rest of it. If you didn't know, if you had a question mark here, follow the rest of it. Let's follow this green circuit. Where's it going? Up to here, another splice. Up to this coil. Should I draw through or stop? Stop. Gotta stop. What's the other side have to be? This is a ground I'm mapping out. This side of this circuit, right, is going to be a power. But here's your ground right here. So everything that I drew in green, is grounded all the time. Now you could make the argument that this circuit, I like the argument, is not grounded all the time. The one I just kind of highlighted in yellow, because this switch would then control it. But everything else that I have in green here is grounded all the time. Does everyone understand that? Can you see it? So this coil, and this coil have a ground all the time. How are they controlled? We're going to control them on the positive side. Power side switched. Because they have grounds all the time. This coil has a power all the time and is controlled on what? The ground side. It's ground side switched. The first two are power side. The last one is ground side. So we need this pump to run. For this pump to run, I need my red circuit to have power. For my red circuit to have power, I probably should maybe separate this. Let's make this red and yellow. That's the pump circuit. My red-yellow circuit going to the pump needs to be powered. The red circuit is hot all the time in the run position. Turn the key on, we get power here. I need this switch to close is the point. You see the dotted line between these two coils? So what that tells you is that coil or that coil will close that switch. Either one. So either one that makes a magnetic field will close that switch. This door, airflow meter, it has a pump cutoff switch. When the door is closed, the switch is open. With the door closed, this fuel pump cutoff switch is open. Does everyone understand that? All right, so what do we need for that door to open? I need airflow. And airflow means I need to open the throttle, engine needs to be running. Okay? Now here's the thing with this system. Cranking was not enough airflow to make the door move. So when you crank this engine over, this switch never closes, this coil never energizes, so the fuel pump never gets power. Everyone understand that? I need that door to close. I need that door to open to make that switch close, to make that coil energize. So fuel pump's not going to run. This car has no prime either, by the way. Not all cars have fuel pump primes. We want to remember that moving forward. So I need something else to make this switch close. What makes this close would be this circuit right here. This is, we said, grounded all the time. So it's power side switched. Everyone understand that? What makes this get power? Ignore this. That's a despiking resistor. Your eye shouldn't even look at that later in life with practice. I'm not even worried about that resistor. That's just for despiking purposes. It has no effect on this circuit whatsoever. Follow this down. What do I have listed here? Hot in crank only. So it's an ignition feed. When I hit the key in the crank position, what am I doing? Energizing the starter circuit, but I'm also doing what right here? Sending power up this way, cranking. This has a ground all the time. We've determined that this is a constant ground here. So as long as I'm cranking, does this coil make a magnetic field? And what's it going to do to that fuel pump switch? It's going to close it. So the moment that I crank this, my fuel pump switch closes and my pump then gets power while I'm cranking. Fuel pump's running. Car starts. Car starts. What happens to the door? Airflow meter door. Door opens. What happens to this switch? Closes. The whole time the door is open, that switch is closed. Now I let off the key, we lose this coil. Does everyone understand that we will lose the magnetic field of that first coil the second I let off the key? Why is that? Because it's hot in crank only. I let off the crank position, the car's running. What just happened? This circuit's hot, was already providing power to the pump, right? We have that drawn here. This leg of the circuit is hot all the time. What did we say about this coil? This side is a switched, it's a switched ground, right? Did we just provide the ground needed for this coil? This switch closed, which did what? Connected this leg of the circuit. I know it's the same color, but follow my ink to what? Ground. So is the car continuing to run? Yes, because this coil took over, made a magnetic field, and is holding that closed. The rest of the time the car is running. What's the safety for this? We need to shut the fuel pump off if the car stalls. We need to make sure that if this car is in an accident and there's a condition where maybe a fuel line gets severed, this is a lead into fuel systems where we're going next week, is we need to make sure our pump does not stay running all the time with the key on. It's dangerous. You don't want to get into a situation where you empty the fuel tank on the ground around you. So we need to make sure if a car engine stalls from, say, a severed fuel line in an accident, that the fuel pump shuts off. Does everyone understand that? This is a non-computer controlled fuel pump circuit. We have to make sure there's still a safety involved. What is the safety? If the engine stalls, if we sever a fuel line and the engine stalls, what happens to the door? The door is going to open, door is going to close. What happens to the switch? The switch opens and then the pump shuts off. Now you get into an accident with one of these and you crush the box and it wedges the door open and you sever a fuel line, you're in trouble. All right, but will you see one of these? Probably not. I don't care. Doesn't matter. What's the lesson? It was a nice review on potentiometers, thermistors, what can be shared, what can't be shared. The reference circuit, the ground. It was also a nice review on power and ground side switching and really how to dissect and read a wiring diagram. Things like what we can draw through and what we shouldn't draw through would be the real takeaway with this.
I hope that you've got something out of that video. The fact I showed that to you was more to give you the idea that wiring diagrams, you need practice and experience, but there's things that we can tell. We can tell when something's got power and when something's got ground. How do we complete a circuit? We have what? A resistance in the circuit, we have power, and we have ground. So all circuits are powered and ground. But how they're controlled can change. We can control a circuit by switching the power on and off. We can control a circuit by switching the ground on and off. We can actually control a circuit by doing both. A lot of modern cars now, they do both with pulse width modulation of changing the amount of current going through both the power and the ground. So there's a lot of things that we need to understand in an electrical circuit, but the principle behind it all is we have to control the power or the ground, okay? And he talked about different switching. He talked about power on switching and ground on switching, okay? And he might use a different term, but that's what he was talking about there. All right? Now, we all have this wiring diagram, okay? You've all got that? Yes. Who has not one? Anyone? You've got one? Is there a spare one somewhere? So I've got a few here. Everyone else has got one? Okay. Where do we start with a wiring diagram like this? Where do we start? Where would be a good place to start?
Battery.
The wiring diagram? Where? Battery. Who said battery? Okay, anyone else? So, look at that. There's our battery. Okay. So, what do we know about the battery?
It is the main power source.
The main power source, doesn't it?
Yeah.
So, like I did with the starter motor, we worked our way back. Now, if I had a red highlighter, who's got pens? Everyone's got pens?
Red.
I want you to draw a line, a highlight from the power, okay? Follow the power line. Also, if there's a dot, see there's a dot? That means that wire is joined to that circuit. So, obviously, there's also power. There's also power along here. There's also power back down here to that relay. Okay?
So what
Now we also see there's an ignition switch. See the ignition switch is the key there? Obviously, when the key's turned on, okay, when the key's turned on, we actually get power going back here. And we can see there's a override switch. I think that override switch is exactly what Paul Denner was talking about when we have a car accident, that we can cut off the ignition through that switch, and that switch would be activated and opened up when the conditions are right for the car to start. You see that switch? Okay. If we have a look here, we've got what's called an EFI relay. Okay? We can see that switch is open, but if that switch was closed, we can see we get powers to what? What's that down there? Injectors. Okay, so here we have a relay. See the relay? We can see it comes on the ignition side. So when the key's turned on, okay, we now get power where? To that relay, don't we?
Yeah.
What controls that relay? What's down here? What do you think that is?
Computer.
No. Is this going to be another power line down here?
Sensor.
I beg your pardon?
Speak sensor.
We've already got power up to here when the key's turned on, haven't we? See the power going down there? So what must this be?
Ground.
Who said ground? Good. Okay, that's how we look at a wiring diagram. Once we know where the power's coming from, it's got to be a ground on the other side. It's got to be a ground. If we have a look at this. If we follow this down, look at the dot here. We're joined to what? And what's that symbol down there called?
Ground.
A ground. You see how we can tell that's a ground?
Yeah.
Okay? Also, if we come back and follow this all the way to this other relay, which is a fuel pump relay, is that a power? Is that power? Ground. Because why? It's joined to the same ground, okay? So what's this one now?
Which one, sir? Which one?
The one at the top.
Positive.
Sorry?
Positive.
And where's the power coming from?
Coming from the ignition.
No, the ignition's here. Where's it? What's it coming from?
Oh, battery.
What's in here? What's that?
Power control.
So the power control module is controlling that relay, and that's a power on switch relay, because the control module powers it up, and then it's controlled by the power. Does that make sense?
Yeah.
So if you looked at the relay first, you wouldn't know which way it was. You wouldn't know if that was powering it or grounding it. But now we know. That's how we look at wiring diagrams, and that's how we work it out. Do we all make sense?
Yes, sir.
So let's assume that I wanted to now look at the fuel system, the EFI system, okay?
Yeah.
I've already done the homework. I wish I brought I have a whole heap of highlighters. I wish I brought them in, I forgot to. But I would have liked you to map it all out this way, but I'll show you how I've mapped it out. I'll look at the next slide. See how I've got all the powers in red? Okay? Where I've got orange is still power because it's going through a relay. It's transferring power. So that's why I put that in orange. So when the relay's activated, then those injectors are activated. But that is still a power. And look at the green. Everything's in green. Everything is the what? What's green stand for?
Ground.
Ground. Does that look a bit more manageable for us if we see that? Okay. So if I have a problem, that I don't have an EFI working, I've got now a map of where all my powers are and where all my grounds are.
Yeah.
I can now go to that vehicle, wherever I can access that wiring harness, I can work out whether I've got power. For example, if I know that this relay here, this is the EFI relay, has to work for the fuel pump relay, okay? And I find out that if I don't have power going to that solenoid, obviously I don't have power going to this relay, and I see there's a fuse there. Where am I going to look?
Fuse, check the fuse.
Fuse.
Fuse number
I've got a
11.
wiring diagram, map it out. Does that make sense?
Yeah.
Okay. Do you know why these are all grounds on the computer? Why are they all grounds on the computer? It tells me. See the ground?
Yeah.
They're all joined together. It's pretty simple.
Yeah.
If I wanted to check my computer for powers and grounds, I also know where all my powers are and all my grounds are. Okay? I also have some grounds here. How do I know these are grounds? And I've got a different colour.
Yes, sir.
Because I have power when this relay's on to my injectors, and you notice all those powers are all consistent. They're all in the one circuit, okay? And I also see, I know that to complete the circuit, I need a ground, okay? So I have a ground, yes.
Chista.
This is gonna visit the washroom, right?
All right. Now, so we were saying to understand how easy it is to map things out, okay? All right. We'll go to the next video. Not video, the next slide. This time I want to look at my DIS. What's DIS ignition? DIS ignition. DIS ignition is distributorless ignition system. Okay, DIS. In the time that we had a single coil, we then went to three. So it's a 6-cylinder, 3 coils, a 2-cylinder, 2 coils. They're called DIS, where they didn't have a distributor, but they had waste spark ignition coils. Y spark ignition coils are coils that spark together. So when you're on compression or exhaust, they're sparking together. So even though you might be on a compression stroke, you've got compatible cylinders that work together up and down, pistons going up and down. And those two cylinders going up and down are companion cylinders, I should say. And those pistons work together. So one will be on compression, one will be on exhaust, but they work together. So they spark together. And that's what a distributorless ignition system had, Y spark coils. So they only had half the coils to the number of cylinders, in other words, because of the way the pistons go up and down together, okay? So this is a Y spark ignition system, and distributorless ignition system also. So let's have a look at that. So here we are. Here's our module. See that? That's our ignition module. Okay? And this is the circuit. We still have all the same powers. Here we have power going into the ignition. We banked it out, right? We still have all the grounds. We don't know where the ground is on this wiring diagram. And remember Paul Denner? He had a little bit of an insight on the one he looked at because he could see inside the computer. But this one, I cannot see inside the computer. I got some things. I've got a crankshaft referencing point. Crankshaft earth, so there's an earth. So I do have an earth there. EST. What's the EST? I didn't know. I'm getting rusty in my old age. Ignition
Switch.
Anyway, I don't remember what S stands for, but EST is to do when the computer takes control. When the computer takes control of the ignition timing. Okay. So we will start the car with a static timing setting that's set in the factory. Once the car gets over a certain RPM, then the EST takes over. So that's what that is, okay? Just so you know. But, you know, we know that. We know there's an ignition bypass control circuit. But anyhow, I want to know a bit more, so I've dug up another wiring diagram. I've dug up, here's our ignition module wiring diagram. I now have more information. Okay, there's my earth. I can see my earth.
Electronic spark timing.
What is it?
Electronic spark timing.
Okay, electronic spark timing. EST. I knew it was to do with timing, I just couldn't remember that. Thank you. So now I can see my earth. See, I can draw my earth, and you can see here. This is in the computer, the power control module. We're listening. The power control module has a ground circuit, and we have a crankshaft signal.
Yep.
Can we be quiet so I can talk myself?
Biswa.
The more you talk, the louder my voice becomes, the more I lose my voice.
The next one who talks, bring him in front of me.
I will. Okay. So, Keanu, what are you doing down the back? Keanu. Okay. Make yourself a note. Okay, so
Make yourself comfortable.
inside the computer, the signal comes in, and each transistor for that signal, for the cam angle signal or cam sensor signal, crankshaft sensor signals come in. With that information, it will then send a signal back to the ignition module. The ignition module will know at what time then to ground the coil. When it grounds the coil, it sparks the ignition, okay? So we have a bit more insight by that wiring diagram. We still have the same power. See the power circuit that we had before in that other wiring diagram. So as we signal out a certain circuit in our wiring diagram, often if we don't have enough information, we can go to maybe a more specific wiring diagram of what we're looking at, which that one is, okay? So just to get used to seeing wiring diagrams, deciphering what they're telling us and trying to understand. I'm just giving you an overview at the moment, okay? I don't expect you to know everything from what I'm saying, but what Paul Denner said in his video was practice, practice, practice. Grab some wiring diagrams, Start marking them out. Get used to using some highlighters so you start to see how the circuits work. Always remember, we've got a power, we have a ground, and follow the circuit, okay, and get familiar with doing that, all right? Without a good wiring diagram, we are lost. A wiring diagram is our roadmap when we're looking at problems. If we don't have a roadmap when we go on a trip, we're not going to go on that trip or we'll get lost. I know we don't actually have maps like we used to. We have our
GPS.
navigation GPS, but you know, in the old days we had to map out how we were going to go to a certain place, and we needed our roadmaps. Okay. Well, with cars, we need a roadmap to see how things work, and electrically, you know, things work with certain electrical principles: powers, grounds, and a load or a resistance. Okay, we need to know that.
In a vehicle.
Any questions?
From that.
Are we getting to understand what I'm saying a little bit, or is it a bit
Little bit.
complicated? Sorry? A
Little bit destiny. Yeah.
It's saying 80. I shouldn't send you to do what I care, should I? It's all
Saw
good.
in the video.
This is the 15% we don't know, okay? Is what we see on the wiring diagram. The 85% is what I'm teaching you. Okay?
Send me that one, the clothes.
What was that? Okay, the other thing on wiring diagrams, we've got workshop manuals to locate grounds. Sometimes we want to know where our grounds are, we don't know where they are, but this is out of the title wiring diagram, and it's showing you the different components that are ground through a junction box. A junction box is where all the terminals come to one point, okay? And then from that one point, it then goes to this ground point. And it's got a symbol of ED. I don't know where ED is, but we'll go to another section in the workshop manual, and it'll show you on an exploded view of the position of ED, which is a ground point, okay? So that sort of information is necessity and necessary for us to be able to possibly locate these points where we could have a bad ground somewhere, okay? Also, our factory wiring diagrams will give us our power. It'll show us where our power comes from. Our power starts from the battery, goes through to the fusible links, through to our fuse box. And this is what we've got here, is a diagram of all that. Okay, so that's another important part of getting used to looking at workshop manuals and using them to our advantage. Okay.